All right, everyone, we are on chapter 5 now, and chapter 5 is concerning energy balance. So, um, there's a couple of things that I'm going over that are not necessarily in this chapter. So, and then there's a couple of things that I covered in chapter 1. So, some things I covered in chapter 1 was what is a calorie? What's the definition of a calorie? So, remember, a calorie is just a measure of heat, a measure of energy. So a calorie is the energy needed to raise a kilogram of water 1 degree Celsius. Some definitions say a liter of water. That's a liter of water or a kilogram of water 1 degree Celsius. Um, and then you should know how many calories are in each of the 3 macromolecules we discussed. So roughly 4 calories per gram for carbohydrates, 4 calories per gram for proteins, and 9 calories per gram for lipids. So we're actually talking about lipids right now, lipids in our body. So in our body, we call fat stores adipose tissue, and we call fat cells adipose cells. And their job is to store triglycerides, store fat that we eat. And there's different measures of calorie content of fat, but generally it's about 1 pound of adipose tissue or 1 pound of fat contains 3,500 calories. So that if you were to eat an extra 3,500 calories more than you burn, you would gain a pound. And then the converse is true. If you were to burn 3,500 calories more than you consume, you would lose a pound. It's not as simple as that, though. So weight management, there's many components there's many parts to losing weight. And so there's your general metabolism, which your book calls resting energy expenditure, REE. Resting energy expenditure, or it's like your basal metabolic rate. It's how many calories you burn just by being you and not doing anything extra. So you have your basal metabolic rate. How many calories do you burn a day just by existing? Then you add to that physical activity. And then you add to that the thermal effect of food. So, so again, your book calls that resting energy expenditure. So your basal metabolic rate, there's things that affect your basal metabolic rate. Let's take a closer look at it. What affects your basal metabolic rate? Age. As you get older, your metabolism slows. As you have, the more adipose tissue you have, that tends to lower your resting energy expenditure, or BMR. Conversely, having more muscle mass raises your REE. Your height influences it. The taller you are, the more calories you burn. The shorter you are, the fewer calories you burn. There are some other things that can affect your metabolism. Being sick or being stressed out. Smoking is also an appetite suppressant. I'm not advocating it, but thyroid levels, being hypothyroid, which many people are, that your thyroid regulates your metabolism. So then I added a few things underneath in smaller font. Malnutrition, meaning like extreme dieting, fasting too much, extreme diets, putting yourself on 500 calories a day, you're lowering your metabolism. Sleeping too much, more than, let's say, 8 hours. After you're an adult, you should be sleeping somewhere between 6 and 8 hours. So how do we calculate that all? We use a body mass index. Another thing that's not necessarily in chapter 5, but it's good that you know it. A body mass index is more accurate than just taking someone's weight. Not saying that body mass index is in itself completely accurate, because it's not, but it's taking someone's weight, it's taking their height into account. So how is somebody's weight compared to their height, because someone that's 6 foot and someone that's like 5'4", they might weigh the same, but that doesn't mean that somebody's overweight. It just all depends. But even then, there's better ways. It's just that BMR is like the way that the general practice, right? So we use BMI, body mass index, and I just put some numbers here. Over 25 is considered overweight, and over 30 is considered obese. And then within the obese range, we have like 3 different categories. There's like morbidly obese and things like that, right? So, how do you figure this out? Well, I mean, there's a calculation, but really you can calculate it on your phone. So, where the body fat is distributed is sort of important. It's important. I mean, having it where you don't want it is in your abdomen, your gut. So that's we call that central obesity. Not necessarily good. Having extra weight in your hips, some other places on your body, that's not necessarily correlated with certain diseases that like hypertension and stroke and type 2 diabetes, things like that. Right. So generally, we have another thing that we use is like a waist circumference. So you don't want over 40 inches in men and over 35 inches waist circumference in women. So why are people overweight? I mean, there's generally a set point theory, meaning that our bodies have like a thermostat, and we set the thermostat to a certain place, and that's it. So that if you take in more calories, your metabolism might go up to adjust for that. And if you take in fewer calories, your metabolism will go down to adjust for that. Right. So that's called the set point theory. But there are hormones that influence weight. And some people say, well, I have a genetic thing. Well, that's true. There is a genetic component. And one of them is a gene that codes for leptin. And as you see here, leptin encourages energy expenditure and suppresses appetite. Right? And then there's another hormone that's released. For example, when you sleep fewer than 6 hours a night. 1 second. Yes. Called ghrelin. So that is released, and that encourages you to eat. So sometimes when you don't sleep enough, you might think, well, why am I like extra hungry in the middle of the night? There you go. Right. So another thing about your adipose cells, your fat cells, is that they have enzymes associated with it. And this enzyme is called lipoprotein lipase. That's not in your chapter, so this is more like FYI. Actually, this whole slide is FYI. But I thought you'd like to expand a little bit on chapter 5. So the more fat cells you have, the more enzyme you have. So when you lose weight, when one loses weight, the adipose cells shrink down, but they don't disappear. You're not getting rid of cells. When you put on weight, you're adding cells, but you don't get rid of them. So you add cells as you gain weight, but then if you lose the weight, you're not going to lose the cells, but you do lose the content of the cells. So they get smaller, so you can get back down to whatever weight you were at one time. It doesn't mean that inside that those cells are gone, right? So theoretically, you have more of that enzyme in you that just wants to store fat, right? So sometimes we think that like all these things are working against us when we're trying to lose weight, and you're absolutely right. Your genetics is working against you, your physiology is working against you, and of course, the toxic food environment around us is working against us. And they've spent a lot of money to design food that pushes our buttons. So what can people do for, what are some overweight treatments? Again, not necessarily in your book in this chapter, but I thought, again, like FYI. So there's a few different things you can do. You can try to speed up your metabolism, You could try to block fat, or you could try to curb your appetite. And so speeding up your metabolism is not a very good way to lose weight, but it's a lot of those treatments out there. One of them, called Fen-Phen, phenylpropanolamine, was pulled off the shelves a long time ago because it was messing with people's hearts. I would say that ephedrine does the same. Pseudoephedrine is something that's used to make meth. So it's like there's those reasons that these things are pulled off the shelf. You have to speed your metabolism so much that it's not really good for your heart in order to lose weight. Another way is an appetite suppressant, right? So serotonin, you might have heard of it, that it helps with sleep and things like that, but it also can suppress your appetite. And St. John's wort, which is available over the counter, is that does it does enhance serotonin, which is one of the functions of serotonin, is an appetite suppressant. But it has many functions, right? And sibutramine is one example of what we call an SRI, serotonin reuptake inhibitor. So you might have heard of NSRIs, norepinephrine serotonin reuptake inhibitors, or SRIs. They don't work all the same. So an SRI might be used to help with your mood. It might be used to help you sleep. It might be used to help you lose weight. Just because it's used for one function doesn't necessarily mean it's going to help you lose weight. So if you're taking an SRI for like your mood, that it could put on weight. Some of them have a side effect of gaining weight. So it just depends, and there's a long reason, there's a long story behind that. But Ally, which was called Orlistat, is available over the counter. So you could just get Ally, and it blocks lipase. It blocks the enzyme that breaks down fat. So if you block the enzyme that breaks down fat, then it doesn't get absorbed, but it's going to pass through you. So you have to think about that. And there we go. So, make sure you know how many calories are in each, or in lipids, carbs, and proteins. Make sure you know what a calorie is, what is it measuring, and then know the different factors for resting energy expenditure, which I'm calling basal metabolic rate in this lecture, but it's resting energy expenditure. As you add physical activity to that, then that goes up, right? You can add your total number of calories that you burn per day. And then there's the thermal effect of food, which we don't really consider a lot, which you shouldn't really consider, but the thermal effect of food is the calories that you need to break down the food that you eat. So it's generally 10% of the calories. So if you eat a candy bar that's 300 calories, 10% of those calories, around 30 calories, are going to be used just to break down the candy bar. So there you go. That is week 5, and good luck to you on your upcoming test.